Yeah, so the first exercise is about physical quantities and units, right? Why does this not there? Good. Okay, so the first exercise is about physical quantities and the units, right? So let me write what we will be doing in this chapter. Units and measurements. So this is the exercise 1.1, right? This is from the chapter motion, forces, and energy. Right, this is the first chapter that we. So the sub chapter that we have is this, right?
Yeah.
So in the first part, we will be talking about what are physical quantity,
Yeah.
right? And then we will be talking about units,
Okay.
right? And in units, we will be talking about some of the basic the units of some basic physical quantities, right? Which are length and time, right? Mass is there in the next exercise, right? So mass is also there, but that is there in the next exercise, right? And then we will be talking about different kinds of shapes, right? Different kinds of geometrical areas, volumes, and all those things. So in this length part, we will be also talking about areas and volume. What is the area of different kinds of shape? What is the volume of different kinds of shapes? And what is the unit for that? Right.
Yeah.
And then we will be talking about representation of these physical quantities. And to represent these physical quantity, we have to understand their significant figures.
Okay.
Right. So let's say that we are measuring a table, right? We are measuring a table, and let's say that we are only measuring this length of the table, not the breadth, but the length of the table, right? And I write it as let's say 1.54678322549 right? But this is not needed. This is not needed. I only require this much information. So I can write it 1.55. This much I only need, right? So this value will justify the measurement of this table, the length of the table. So the figures, the number of figures we require to justify a measuring. That is what we call the significant figures, right? So to represent the measurement of this table, we only require this much significant figure. Right? We don't need all these things. Let's say if I want to measure an amoeba, right? This is some amoeba, this is some nucleus, right? And this is cytoplasm, so this is some amoeba. And this amoeba would be in some millimeters, right? So I have to write it as 0.04, let's say 25. So this much measurement I require, right?
Yeah.
To represent the size of the animal. So for different kinds of measurement, we require different kinds of significant figures, right? Because these details are important for the measurement of the animal. So that is why we require a very fine measurement of amoeba. For this table measurement, we don't require this much of significant figures, right? Let's say the size of the earth. This is our earth, right? And the size of the Earth is 64. So this radius is 6,400 kilometers. Right. So only this much significant figures we require in the measurement of the Earth. So for different kinds of measurement, we require different kinds of significant figures. And in this topic, we will understand what are the rules for significant figures.
Okay.
Right. What do we call a significant figure? Let's say we have this expression 1.5000. So how much significant figures do we have in this representation? Right.
Yeah.
How much significant figures do we have? Let's say, for example, this 0.0054. So how much significant figures are there in this measurement? Right.
Yeah.
So there are certain rules that we follow to represent the significant figures. So this is the third thing that we will understand. And then we will talk about some measurements. Right, and those measurements are vernier caliper, and then the next one is screw gauge. Right.
Yeah.
So how do we use these two things? Right, these two instruments. How do we measure some size of the object from these two instruments? Right, they are very precise measurements. So we can very precisely. Let's say I give you some scale. This is some scale. And it has some measurements, right? It has some markings, right? From 0 to what is the end point? 15, right?
Yeah.
So this is a 15 centimeter scale. And then I give you a vernier caliper, right? So let's see how that is drawn, right? So this is how vernier caliper is drawn. And then we have this measurement. So I give you these two instruments. This is a scale. And then this is a vernier caliper. And then I will give you a spherical ball, right, of this shape. Right, so you have seen some iron spherical balls, iron balls, right? So which of them can accurately measure the size of this iron? These are small iron balls, right?
Yeah.
So then we will see that which one of them can accurately measure the size of these iron balls, right? And you will see that from the vernier caliper, we can accurately measure this because it would be difficult to measure the size of this spherical ball with this scale, right? Can you measure the size of this thing with this scale accurately?
No, not accurate.
Not accurately. We can approximately measure it, right? Surely we can approximately measure it. But if you want to accurately measure it, so we will have to use this vernier caliper. So we fix this ball inside this vernier scale, right? Then we move this thing. So yeah, I will tell you how to measure or how to measure this size of this thing with the use of this vernier caliper, right? So that we will understand. And the last topic of this exercise is the difference between scalar and vector quantities. Right, so these are the things we would be understanding. And of course, there are some errors in the measurement of things. There are errors which are involved. So I will also talk about those systematic errors.
Okay.
So this is the plan of today's talk, right? And yeah, please note it down. So we will be doing all these topics. We'll be discussing all these topics one by one. So please note it down.
So I should write significant figures first?
Yeah, so from physical quantities, units, and measurements, and then all these are things. So these are the subtopics that we will be covering, right?
Yeah.
So this gives you the idea that how should we approach this exercise or this subject, right?
Yeah.
So yeah, then we can understand that what we would be learning in this chapter. Yeah, whenever you have noted it down, then please tell me. Then I can start with the physical quantity, right?
Mm. Yes. I
Okay.
yeah.
Okay, good. So let us start with the physical quantities, right? Before we start, let us understand our basic mathematics rule, right? And that would be important in this chapter. So that basic mathematics that we require is that is powers of 10, right?
Yeah.
So let's say if I have this number, right, 4000000. So how I can easily write this thing, right? So I can write this thing in powers of 10. So this would be 4 into how much zeros do we have? 1, 2, 3, 4, 5, 6, 7. So this is 10 to the power 7, right?
Yeah. Yes.
So, and this is what we call the scientific notation.
Mm. Okay.
Right. So we can write these large numbers or even this number, right? If we are writing the decimal numbers, let's say 0.1, right? So this is what? If I solve it, so this is 0.1, I cancel this thing, so 110 will come downstairs, right? So I can write this thing as 1 into, if I take the powers in the numerator, right? What is the power of 10 in here? What is the power in here?
-1.
In denominator, it is 1, right? So if it
Yeah.
goes in the numerator, it will, yeah, absolutely correct. It will become minus, right? So whenever I'm writing a decimal number, let's say 0.003. So this would be, if I write it directly, 3 into 10 to the power minus 3, right?
Yeah.
So if I have some decimal expansions, so the powers would be negative. If I have these tens, thousand, all these places, so then powers of 10 would be positive, right? Clear?
Yeah.
Okay, so yeah, remembering these things, let us understand what is a physical quantity. So a quantity,
So should I write it down?
yeah, first let us understand this physical quantity. Let us write all these definitions, right? And then, yeah, then I will tell you to write, right? Yeah, so let us understand these things first. So what is a physical quantity, right? A quantity which can be measured with some measurement tools or measuring instrument, and has a definite or has a physical attribute associated with, right?
Mm.
pencils using this way. So okay, so can be measured with a measuring instrument and has a physical attribute associated then it is called a physical quantity. Right. And some of the examples are, what are the examples? Distance. Then you have temperature. You have mass and all those things, right? So all these are physical quantities, right?
Yeah.
And the next part comes, and that is the representation of the physical quantity, right? So of physical quantity, or I should write it units, right? Because in representing a physical quantity, all the physical quantity will have in representation two attributes, right? And what would be those two attributes? Can you tell me? Or two parts? You can define. You can. Yes.
Of what?
Let's say you have a physical quantity, right? Let's say if you have a physical quantity, let's say you have distance, right? Let's say you have this A point and then this B point. And then the distance between these 2 points is whatever. So how will I represent the distance between these 2 points? What are the things which would be associated with the distance? How can I represent the distance between 2 points?
I don't know.
For example, yeah, you can give me an example. Let's say what is the distance between your home and school? Let's say this is your home.
Like
And this
500
is
meters?
500 meters, right? So you have told me two things, right? You have represented distance, right?
Yeah.
And in representing a distance, you have told me two things. What are those two things? One is some number that is telling you the magnitude, and the other one is the unit, right?
Okay.
So whenever you represent a physical quantity, there are two parts associated with it. One is the magnitude and the other part is the units, right? Why unit is important? Why unit is important? If I tell you, let's say I say that I have moved 2 kilometers, right?
Yeah.
So by just looking at this thing, you can always tell me that what is the thing that I am talking about? What is the physical quantity that I am talking about, right? If I say 2 kilometers, then you will you can quickly comprehend, you can quickly decipher that what is the physical quantity I'm talking about, right? What is the physical quantity I'm talking about?
The distance.
Distance, right? So by just looking at the units, we can identify what is the physical quantity I'm talking about. Let's say I say 4 kgs, right?
Yeah.
Then by just identifying kgs, you can quickly tell me that I'm talking about mass.
Yeah.
Right. So that is why the units are so much important that by just looking, by just identifying the units, we can talk about the types of physical quantity, right? So
Yeah.
in representation of a physical quantity, you have two parts. One is the magnitude, which talks about how much, right? And then you have units. which talks about what? Right. What is the thing that you are talking about? So that is the representation of a physical quantity, right? So now we can define the units, right?
Yeah.
So let us define units. So these are the units are used to represent a particular physical quantity, and they are really helpful in identifying kind of right.
Yeah.
For example, the basic units that we have in our daily life. So some of them are length, which has a unit meters, right? And then we have mass, which has a unit in kg, and then we have time, which has a unit in seconds, right? So
Yeah.
these are the basic units that we have in our daily life. And we will be talking about these things in detail, right? So yeah, please note it down. Please note up to this point, and if you have any question, please add it, right?
Yeah.
So we started from where? We started from where, right?
Yeah.
Yeah, so then please move down. And give me one moment. I have picked up this call. Give me one.
Okay.
Yes, sorry, I had to pick up this call. So yeah, whenever you want me to scroll down the screen, please take.
Yeah. What?
Yeah, sorry. Whenever you want me to scroll down the screen, right? Then please tell. So,
Okay.
Whenever you have noted all these portions, then please tell.
Sir, I think I'm done.
Yeah, then please note that.
Yeah, yes.
Yeah. Okay,
Yeah.
so now let us talking about different kinds of. Let's take the example of length, right?
Yeah.
So let's take an example of length, and let's call it measurement of per unit of length. So I can represent length in meters, right? Let's say I can represent length in 2 meters. I can also write, let's say, some other number 3 millimeter. I can also write 5 or let's say 60 centimeters. And I can have different kinds of notations or units for length, right?
Yeah.
So I should know that how I can interchange between these different units, right? So I should remember that how I can interchange between these units. And let's take, for example, let's say that I am in India, right? I represent length in, let's say if I am talking about length, so I say 1 meter, right?
Yeah.
And let's say I'm in India, right? And let's say you are in Saudi, right? So you write 1 meter in, let's say you say 20, whatever, PC, whatever this thing is, right? So let's say this is in Saudi. And let's say one other person which is who is living in South Africa, he is writing this 1 meter as 40, let's say PM, right? Whatever, I don't know, let's say picometer or whatever this thing is, right? So he is representing this length in some different units, right? Let's say he is in Africa. And let's say one person who is in, let's say Iceland, and he's writing 60, let's say cm, right? This is not centimeter but other name, let's say Clay Martin, whatever I say, and he is in Iceland,
Okay.
right? So I am measuring this stick, all of them, let's say me, you, and these two persons, they are all measuring this stick, but all of them have different kinds of units, right?
Yeah.
So let's say if I go to Saudi, then I would be measuring this in this PC unit. Let's say pica carbon, whatever this thing is. Let's say this has a different name. And if I am in Africa, so I'll be measuring this stick in some different units. So there is no correlation between these different measurements. There will be lots of confusion in measuring the same quantity, right? So I have to remember all these kind of units, right?
Yeah.
And this will create confusion, right?
Yeah.
So that is why, what should I have?
Like an organizing.
Organized, I should have a system, right? I should
Mm.
have a system in which we agree to this system altogether, right?
Yeah.
So we decide every people in all of these different ones, all these communities sit together and decide that we should define length with this particular unit, right? We should have an agreement that we define length in this particular unit, not in the other units, right?
Yeah.
Then it will not create any confusion. So I should have a particular system of units which is applicable in everywhere, which is accepted by all. And that is why we have this international system of units, right?
Yeah.
So that is why this solves all these confusion. And in all of these areas around the world, we have particular set of units to define a particular measurement, right? So that is why we need a particular system of units which is
Yeah. Yes.
widely accepted.
I have a very big confusion in
Yeah.
significant figures. The thing is that I I don't really understand which questions I should apply it and which questions I should not. And
Mhm.
which question, like when it's there was this question asked in the max paper,
Mhm.
convert into two significant figures or convert into one significant figure. I don't understand like how I calculate it.
Yeah, yeah. So then we'll talk about when we will be talking about the significant figures, right?
Yeah.
So when we will be talking about significant, so the next topic after this thing is significant figures, right? So
Yeah, okay.
in the rules for significant figures, we'll be talking about we'll be talking about how can we convert, and then what are the things that we have to take care in converting those significant figures, right? So there are different operations, multiplication of different numbers, which will have different significant figures. So what is the final result? How many significant figures should the final result should contain, right? So
Yeah.
all those things we'll be talking in the next set of topics. But first, we need to understand this. We need to understand this system of units, right? So
Yeah.
we need a particular system of units which is widely accepted so that all the people have same set of units to represent a particular. I should not write these things because this is just to tell you, right? So yeah, don't write these things. So to represent a particular physical quantity. That is why we have international system of units which governs the units for different physical quantities. Right. For example, in SI system, length is represented in meters, right? And mass is represented, I will write it in short notation, in kg, and time in seconds. Right, so in all over the world, we'll measure the same quantity in these units only. Then we'll not have any confusion, right?
Yeah.
And sometimes it is also called the MKS system, right?
Yeah.
So yeah, so this is about the system of units, right? So why do we require this international system of units? And how do we measure these different physical quantities, right? So in subsequent exercises, whenever you write, we should always write in SI system, right?
Yeah.
So whenever we will be writing any physical quantities, we would only be writing in MKS system or SI system, right?
Yeah.
So let us do some questions. Yeah, so this was about the length, right? And we'll be talking about the different notations. So let us understand those. This is not important, right? So these things you should not write. Yeah, whatever is the important, I will tell you. So let's say one is that what is 1 millimeter, right? In meters.
Yeah.
So this is 10 to the power minus 3 meters.
1/1000.
Yeah, which is 10 to the power minus 3. So we should write in the scientific notation, right? 1 by
Yeah.
1000 is not a scientific notation, so 10 to the power minus 3. And then we have micro, right? So micrometer, and this is represented in something like this, right? This is mu. So this is called micro, right? So one
Yeah.
micrometer is 10 to the power minus 6 meters, right?
Yeah.
And then we have 1 nanometer. So this is represented as nm, and this is 10 to the power minus 9 meters. And then we have kilometers, right? And we can
Yeah.
also write picometer, right? Picometer. So this is PM, and this is 10 to the power minus 12 meter. And then we have one femtofermi, or this is also called femtometer. So 1 FM, and this is 10 to the power minus 15 meters, right? So this is the size of the nucleus, right? And okay, one more thing is there, that is angstrom. This is written as 1A, and then this, right? So this is a particular notation, and this is 10 to the power minus 10 meters. Okay. So now we are just writing in the negative powers. Now we should write in the positive powers as well. So the first positive power that we have is 1 kilometer. And this is 10 to the power 3 meters. And then we have, let's say, gigameter.
Okay.
So gigameter is 10 to the power 9. Right? So these are the things. And this is also 1 billion, right?
Yeah.
1 billion meters. So these are particular powers that we should do. Okay, please, these are important. So these things you should please note it down.
Okay.
And then now we'll understand the conversion of these units, right? So how we can convert nano, pica, and all those things together. But all of these things we will write in what?
What do you mean? Like in
All
standard?
of yeah, in standard notation, right? So that should be in meters.
Okay. So should I take it down?
Yeah, please note it down, and then we'll be doing some questions. And oh, so we have only 12 minutes left.
Yeah.
Yeah, so significant figures we'll talk about. If we reach that point, so we'll talk about significant figures, right? Because I want to go slowly, right? I don't want to rush so that we skip some information and yeah, the concepts are not created, right? So that I'm not, right?
Yeah.
So I will write specifically all the set of rules that we follow to yeah, to tell you how do we calculate this in number of significant, right? So yeah, I will specifically write all those.
Okay. In 1 second.
Yeah, whenever you have noted it down, please tell.
Yeah, I'm noting it down now. I think I have this in my notebook. We have wrote it like in my physics notebook.
Yeah, yeah. So that is in your school, right? So if the yeah, if you have noted, then I guess this pico and Fermi and angstrom that would not be there, right? These two things are not there in that notebook. So yeah, whatever I'm telling you, all these things are there in your book, right? But
Yeah.
I'm just elaborating those things, right? So yeah, those are already there. So these are the things that we have talked about, right? So these are already there, right? Yeah, but so we have to also talk about area and then right. So let us. These are already there, but whatever is not there, please note it down. So this pico Fermi angstrom that is not there. Please note it down.
Okay.
Yeah, whenever you have noted, please tell.
Yeah. Okay.
Yeah, how much time your teacher took to just complete this 1.1 chapter?
I think we I think like around like 4 to 5 days or 1 week.
Five, oh, 4, 5 classes.
Yeah, so I think it's around 240 minutes.
40
Yes.
minutes.
Yeah, 240 minutes.
Yeah, six. So one class is of 60 minutes, right?
No, one class is actually 40, but then one of the days we have two periods. So
Oh, okay. Yeah. So how many? I guess 6 classes.
yeah, she took 6 classes for the chapter, but then we for the additional like past papers and questions,
Hmm.
she took one, I think another 3 days or 4 days.
In this 1.1 chapter, in this physical quantity and measurement techniques, in this 1.1 exercise or the chapter, in this one only.
Yeah.
Okay, yeah. So we are going fine, right? Okay. Yeah, have you noted all these things down?
Yeah, I have noted it.
Okay, so now we can talk about do we have any questions from the changing of the measurements, right? So far, we don't have. So first, let us talk about the significant figures and then we can talk about, right. So let us talk about the significant figures. So, so significant. So as I told you, what are the significant figures? So they are figures up to which we can represent the number or a measurement which could justify the measurement accurate, right? So let's say
Yeah.
if I'm measuring the height of the bottle, so that should be in a few centimeters, right? So I'm writing, let's say, how much? 15 and then 30. So let's say the height of the bottle is 30 centimeters, right? So I can write 30.5 and let's say 30 point, let's say 24. So this should be enough, right? I should not write 30.5, 43215. So this much precise measurement of the height of the bottle, I don't need. Up to this point, this will justify the measurement, right?
Yeah.
So that those figures are called the significant figures, right? So, and there are the rules of the significant figures. So, rules for number of significant figures in a measure. So the first rule is that all the non-zero numbers are significant. Right. So if I write, let's say 4, 3, 2, 5. So how many significant figures do I have?
But is it two?
Oh, so we have 4, right? We have 1 non-zero, 2, 3, 4. 4 non-zero numbers, right?
Mm, Yeah.
So whatever amount of non-zeros I have, so all those are significant figures. Right? Let's say if I write 46.34. So how many significant figures do I have?
Now it's 1, 2. Yeah, it's 4 as well.
It's 4. So whatever the amounts of non-zero numbers are, those all numbers are significant figures. Right? So this point is very direct. That how many, whatever number of non-zero numbers do you have in your particular measurement, all those are significant figures, right?
Yeah.
And then the zeros between the non-zero numbers are significant also, right?
Yeah.
So for example, if I write, let's say 4025. So then how many significant figures do I have?
3.
No, 4.
Wait,
Because
but
this is,
I
yeah,
thought.
this is, yeah.
No, yeah, continue.
Hey, please tell me, what is your thought?
No. I got confused with something else.
Yeah, so whenever you have the zeros between the non-zeros, so all those zeros are significant, right? So in this one, we have 4 significant figures.
Okay.
And then if we had a number behind or below less than 1, then the number of zeros which are left to the first non-zero number are all insignificant. What I am trying to say? That let's say how do I represent a number which is less than, first number is 0.5, right? This is the number which is less than 1. Let's say I have 0.00432, right? I have 0. Let's say 0.5. I have 0.1234, right? Let's say I have 0.000021, right? So
Yeah.
all these numbers are less than 1, right?
Yeah.
And for example, if I take this number, so this number, what is the first non-zero number that you are getting after decimal?
Should I? Okay. I got it.
Yeah. So after decimal, I should write somewhere after decimal, right? A number of zero which are left to the first non-zero number after decimal are all insignificant, right? So in this one, how many significant figures do I have? In this one, how many do I have?
This one is 1.
1. Right. In this one, how many do I have?
3.
3. Right. And in this one, how many do I have?
1.
Right. So in this one, again, how many do I have?
4.
4. And in this one, how many do I have?
2.
2. So this is how I count the significant figures. Right. And so okay. Oh, we already have yeah. So I will in the next class, I will give you some time to note these things down, or you can just take the screenshot, right? You can just take the screenshot of this thing. So I will, there are other rules as well. We'll talk about all those rules in the next class, right?
Mm.
So yeah, please take the screenshot and then we'll end the class. Okay. And please, the rule of this class, so rule of our class would be that there would be no hesitation. Whenever you have a confusion, whenever you have any question, any doubt, please don't hesitate and then ask the question. Okay. So that is the only rule that we have. Yeah, taking the screenshot.
Okay.